The various paradoxes about what happens in space and in our universe in general have kept scientists on their toes, looking for proof and answers to some questions that have been so hard to solve today. But what are these paradoxes? Let's watch ahead to find out more. Hello guys, and welcome back to our channel. In today's video, we shall be taking a quick look at some of the paradoxes that give scientists sleepless nights. What is a paradox? A paradox is a statement or theory that could contradict itself based on a certain expectation or theory that's already out there. The conclusion is usually rather quite hard to expect, as not enough information to back up these claims exists. Now, as we all know, our universe is so vast that we still have so much exploring. But with whatever little we know, quite a few theories have been making their rounds in the world of astronomy, resulting in the creation of quite a few paradoxes. So let's take a look at some of these paradoxes one by one. The first paradox we shall look at is the Fermi Paradox. The Fermi Paradox was named after Enrico Fermi, the famous Italian physicist who created the first nuclear reactor the world ever saw, the Chicago Pile 1. This gained him quite a few nicknames such as Architect of the Atomic Bomb and Architect of the Nuclear Age. But this paradox doesn't deal with any bombs of any sort, but in fact questions the existence of extraterrestrial creatures. Though there have been UFO sightings, unless solid proof of an extraterrestrial is seen or caught, this paradox is left unsolved. This theory has also considered that the Earth and our universe is fairly young and that there are quite a few older universes whose existence is still left unknown to us. This also brings in the interstellar travel concept that's still quite alien to us, but with improving tech, we can expect to solve this paradox soon. This brings us to another bigger question. How many civilizations could possibly exist out there? The Drake equation, which uses 7 variables to calculate its solution, was brought out to find a solution to this question. Until the mid-1990s, it was assumed that it was only our Earth and its galaxy that existed. But with further space exploration, this theory was proved wrong. Now, according to the Drake equation, there are millions of Earth-like civilizations out there, and the Kepler Space Telescope quite recently was able to get some data to back up this fact. According to the data that was collected by this telescope, there are around 300 million worlds like the Earth out there. Some of them come with water, while others come with a great atmosphere. Scientists are now on the lookout for a habitable land that humans could one day migrate to if the need ever arises. Space is made up of vacuum, and as we all know, sound doesn't travel through vacuum. But apart from this being a major reason why space is quite quiet, why is our universe silent? And by silent, we mean why is there no activity in space, such as some hustle-bustle by some extraterrestrial creatures or a few planet invasions and so on. Though this may sound like it's a science fiction movie script, the possibility of this happening still exists. Moreover, only getting our hands on one of these extraterrestrial bodies, that is, if they exist, would put an end to quite a few theories and paradoxes. The bootstrap paradox is another paradox that questions the concept of time travel in great depth. Let's take an example of the Mona Lisa. So the Mona Lisa is quite a masterpiece, and we all can agree on that one. So let's take a hypothetical example to shed better light on what we're trying to convey here. So imagine the Mona Lisa is now up for grabs and someone buys it. It is then sent back in time and lands up in the hands of Leonardo da Vinci. On seeing this, he creates this exact same art piece, leaving everyone to wonder which of the two realities is actually real. Another paradox based on time travel is the grandfather paradox. This paradox involves going back in time and eliminating the grandfather from the family tree. Without a grandfather, there would be no family tree left, and it would be the end of a family line. This could also result in the creation of alternate realities or even parallel universes in which the truths vary quite differently. The Hitler paradox is quite similar to this paradox as well. In the Hitler paradox, eliminating Hitler by time traveling into the past would be the goal, but in doing so, the consequences could be either positive or negative. And to know which of these two would prevail, we would actually have to experiment with it to find some well-defined results. Removing Hitler from the world would mean that the world never faced World War II, and that could mean a new timeline would be created. This also means that the reality could either be better or worse. And in the case of it being worse, we cannot imagine how much worse it could be than what happened during World War II. In fact, to know for sure, one would have to experience it, and that also raises another paradox that's known as the observer's paradox. One of the most famous paradoxes out there includes the paradox behind the double-slit experiment. This experiment is conducted while teaching physics to young kids. In this experiment, a screen with slits is taken and placed in front of another screen behind it. Tennis balls are then hurled at the screen that comes with slits. Only some of the balls end up passing through the slit and land on the screen that's placed behind it. On looking at the pattern created by the balls in the second slit, it's pretty evident that it mimics the design of the slit which was present on the first screen. Now, when the same experiment is conducted with light, the results are quite different. Photons, which are a constituent of light, pass through the slits but don't form any particular pattern on the second screen. In fact, an interference pattern is formed, making it seem like a light has passed through all the slits on the screen and not just one. This again brings about questions about the nature of photon. As far as we know, photons keep charging their behavior depending on the environment that they're present in, and this further opens up many more questions. Theories in black holes have been produced by quite a few scientists over the years, one of the most famous theories being that of Stephen Hawking. The man was a pure genius, and whatever he had theorized seems to be true. With all the advanced tech that we have in the world, we were able to create huge telescopes to further understand the concept of black holes and understand its nature. The black hole information paradox is a paradox that's backed up by concepts from quantum mechanics and general relativity. The paradox states that physical information can disappear permanently. For example, a paper consisting of some information can disappear forever if it's burned to ashes. But even the ashes consist of some information to trace them back to what the paper originally was. Scientists tried using the same concept with black holes and tried tracing it back to the content that black holes swallow up and radiate out later on. To further elaborate on this, quite a lot of matter that's found in space is swallowed up by black holes. This could range from asteroids to even planets. So after they swallow up the matter found in space, they throw out the same matter in the form of radiation. Unfortunately, the radiation that's given out comes with no beneficial information which we humans can study further. The radiation that's given out is known as Hawking radiation. We all know how that name came about, and thanking one of the most important radiations out there in space after Stephen Hawking itself was the least we could do to thank him for his highly advanced theories and concepts on the black hole. Furthermore, the new generation of scientists have discovered something quite new in regard to the black hole and the radiation that we were earlier talking about. These scientists have stated that an invisible surface that lies inside the black hole, called the quantum external surface, was recently discovered. The surface encodes the information that was radiated, hence allowing it to escape from the surface of the black hole. The number of paradoxes out there is countless, and hopefully, in time, we're able to solve them all. And that's all for today, and we hope you enjoyed our video. Drop this video a like, subscribe to our channel, and turn on your post notifications to receive the latest updates from our channel. Bye and see you soon!